Hey everyone, this is Carrie and I'm one of the Chem 4 PAL leaders, and today I'll be doing a video segment for exam number 2, practice exam D, problem number 17. So please pause the video and take a moment to just read through the problem and let's see what we're trying to solve for. Now that we have an idea of what's going on, let's get started. Now if we take a look at this problem, this question is asking us to calculate the mass in grams of a sample of brass that is 58.0% copper and has a volume of 0.336 inches cubed. Based on the information given, we know that we are going from a volume, inches cubed, into a mass in grams. Now, since we cannot directly convert from inches cubed into grams, we must find or use a conversion factor between these two units. Since we're going from a volume to a mass, we can use density as a conversion factor. With the given information above, we can definitely find density. And density is just mass over volume with the units of grams over centimeters cubed. Now the bridging factor between inches cubed and grams would be centimeters cubed. So our flowchart will look like inches cubed going into centimeters cubed into grams, since we're going from a volume to a mass. Now that we have our flowchart, let's write in our conversion factors. These will be the conversion factors that we will be using in order to solve for the mass in grams of a sample brass that is 58.0% of copper and has a volume of 0.336 inches cubed. When going from inches cubed into centimeters cubed, we are using 1 inch cubed over 16.41 centimeters cubed. And we're going from centimeters cubed into grams. That is the conversion factor that we are solving for. And recall that 1 inch over 2.54 centimeters, that quantity cubed, is just equal to 1 inch cubed over 16.41 centimeters cubed. Let's look at this animation to help us better understand the underlying concept and overall idea of what an alloy is. In this animation, we have a cylinder of brass which contains both copper and zinc molecules. The copper molecules are represented with orange circles, and the zinc molecules are represented with gray molecules. Notice that the fraction abundance of each type of molecule is different. When reading this problem, think back to the first exam when we had calculated atomic mass using isotope, fraction abundance, and mass. We can use the same setup to solve for this alloy density. Because both are weighted average, we can transform this old equation into a new equation for the density of alloy. Now that we have our equation and we know what we're looking for, let's fill in our table of what's given, equations we need, and our unknown. What's given to us is the percent copper. The percent of copper in this alloy is 58.0%. And the density of copper is 8.92 grams over centimeters cubed. And we can solve for the percent of zinc by subtracting 58.0% from 100%. If you cannot recall how to do that, please reference Magda's atomic mass calculation video. And we know that the density of zinc is 7.14 grams per centimeters cubed. And if you're wondering where I got density, flip onto the first page of this practice exam and the density is there, and we can definitely use that for this calculation. The equations we will need in order to calculate the density of alloy is represented above. So it's the equation above that we're using. Density of alloy equals density of alloy 1 times fraction abundance of alloy 1 plus density of alloy 2 times fraction abundance of alloy 2. And what we're looking for, our unknown, is the density of the alloy. Now that we know what equation we're using, let's transfer that equation so it pertains more to this specific problem that we're looking at. So I rewrote the equation as density of brass equals density of copper times fraction abundance of copper plus density of zinc times fraction abundance of zinc. Now that we have our equation, let's fill in what we know. We know the density of copper is 8.92 grams per centimeters cubed, and the fraction abundance of copper is 58%. Well, it's a percentage, it's not really a fraction. But hold on to that thought, we'll definitely get to that. And we know that the density of zinc is 7.14 grams per centimeters cubed, and the fraction abundance of zinc is 42.0%. Now we have to label our significant figures because we are such great students and we want to be precise. Each term in this equation has 3 significant figures. And you're probably wondering, well, the original question said fraction abundance, but we have percent abundance. So in order to transform that percentage abundance into fraction abundance, we have to divide each percentage by 100. And we're left with the following equation. Now again, because we're precise students and we're such great students, we want to label each significant figures. Notice that the 100 is an infinite number and has infinite significant figures. Now after dividing through the 100 for the percentages, we are left with the following equation. And after this equation, we would also want to label our significant figures. And each term has 3 significant figures. After doing so, we multiply through and we get the following equation. Notice that now we're shifting from significant figures into decimal places. And labeling each term, we have 3 significant figures, but then we have 2 decimal places. And after we add, we're left with 8.1724 grams per centimeters cubed. And this would be in 2 decimal places, 3 significant figures. Notice that this is not our final answer because our final answer is to calculate the mass in grams of the sample of brass. And notice that we have the units grams over centimeters cubed. This can serve as our conversion factor when going from volume to mass. So what we found is not the final answer. And since it is not the final answer, we do not round off until the end. Now it is time to solve for the mass in grams of a sample of brass that has a volume of 0.336 inches cubed. Step 1. Start with the flowchart. Flowcharts are so important. It's so important to start with your flowchart going from inches cubed into centimeters cubed into grams. Step 2. Write in your conversion factors. Remember that when going from inches cubed into centimeters cubed, that has an infinite amount of significant figures, and when using the quantity 1 inch cubed equals 16.41 centimeters cubed. And originally, we did not know how to go from centimeters cubed into grams. We did not have a conversion factor for that, but we just solved for it. And that quantity has 3 significant figures, and is 1 centimeter cubed is equal to 8.1724 grams. Step 3. Start with 0.336 inches cubed and use the flowchart to help you get into grams. And we notice that our units cancel out, inches cancel out, centimeters cancel out, and we're left with grams, and our answer is 45.0 grams, and that is the letter D. Now that we have our answer, what did we learn in this video? We learned that chemistry is cumulative, and what we learned in the first exam is what we'll need for the next exams. And we also learned that flowcharts are very important. Without flowcharts, we cannot find our answer. And another important aspect to this video is that write out all your units and their significant figures. Show all of your work. These are all the important skills that you should have learned from this video, or should have gained from this video. Just an ending quote, when an electron hits you hard with its negativity, stay positive like a proton. Good luck to you on your exam, and best of wishes from your PAL leader.